Here we are asked to use arrow notation to describe the local behavior and end behavior of the functions 1 over x and 1 over x squared. And we see graphs of those two functions already produced on the screen here. On the left, we have the function, so this is the function 1 over x on the left. And on the right, we have the function 1 over x squared. All right, and we're going to use arrow notation to do this. So let's look at the local behaviors. So local means sort of on the insides, and some functions, more complicated functions, will have important local behavior at several points. Here, the way I look at these for these functions, there's interesting things happening near x equals 0 on both of these functions. And so we want to look at what's happening near x equals 0. And what I can see is that the behavior is different on either side of 0. And so here's what I see. I see that as x is approaching 0 on the left-hand side, the function is moving downward with no bound. And so here's how we write that with arrow notation. For this function, we can say as x approaches 0 on the left. So we put that little negative where we would normally put an exponent. And so what we're saying is from the left, from the negative side, from the lesser side of 0. As x approaches 0 on the left, the function f of x is approaching negative infinity. The function decreases without bound. However, if I approach 0 from the right, we're up here. As we are approaching 0 from the right, the function is increasing without bound as x approaches 0 on the right. And so that little plus sign in the superscript for 0 says we're approaching from the right, from the greater side. As x approaches 0 from the right, the function approaches positive infinity. The function increases without bound. Now let's contrast that with the function f of x equals 1 over x squared. And we again see some interesting behavior near x equals 0. However, for this function, on both the left and right-hand side, the function is increasing without bound. And so we would say, as x approaches 0 from the left, the function approaches infinity. Similarly, as x approaches 0 from the right, the function approaches infinity. So that's the local behavior for the functions near x equals 0. Now, what about the end behavior? End behavior says, what's happening far to the left or far to the right for the function? And so what I see here is far to the left. As I move further and further to the left, the function is getting closer and closer to 0. The function is getting closer and closer to the x-axis, to 0. And so as I move further to the left, as x approaches negative infinity, the function approaches 0. And as I move further and further to the right for the function, again I see the function approaching 0. As x approaches positive infinity, the function approaches 0. And for the function 1 over x squared, we see similar behavior. As x approaches negative infinity, the function approaches 0. And as x approaches positive infinity, the function approaches 0. So as x approaches negative infinity, the function approaches 0. Similarly, as x approaches positive infinity, the function approaches 0. So there is some arrow notation to describe the local and end behavior for these functions.